In this example, we want to find and verify the inverse for this function f of x. And we'll state the domain and range for the inverse of f of x. So let's do the find part. We go through it kind of quick. The previous example, I take a little bit more time to explain exactly what's going on. But what I like to do is take this f of x out and replace it with a y. So that's f of x right here. And then what we want to do is we want to try to find the inverse. So everywhere we see a y, we're going to change that out for an x. We're just going to switch the x's and the y's. And then we're going to have to solve here for y. When we're solving, we want to use, so for solving here I'll write, use reverse order of operations. I like to state the order of operations with GEMA. You can use PEMDAS if you'd like. For me, the G is grouping symbols. The E is going to be exponents, and that'll include square roots. And then we'll do multiplication, division, and all in one line, and we'll do addition, subtraction. Remember, this is for evaluating a function. We want to go in reverse order. If there's any addition or subtraction inside a grouping symbol, we'll do it last. Anything that's outside of a grouping symbol, if it's addition or subtraction, we'll try to do that first. So let's try to use that process here on this equation. We have multiplication here. We have stuff inside a grouping symbol. We have an exponent. And then we have some addition here. Remember, we want to get rid of that first. So we're going to subtract 2 from each side. So we've got x minus 2 is equal to 2 times y minus 3 quantity squared. We now have multiplication, grouping, and then an exponent. So we've got the addition subtraction part done. We're going to now go on to the multiplication division part. So we just do the inverse of multiplication here, which would be division. I like to use a long horizontal fraction bar here. You could definitely make this x over 2 minus 1. That would be fine. But some students, will forget to do the 2 divided by 2. So I like to just kind of leave it like this, although you can totally split that up. Now we've got x minus 2 over 2 equals y minus 3 quantity squared. Notice how we need to solve for y here. That's our goal. And we're doing that by going reverse order of operations, just unpacking this whole thing. Exponents are next, so to cancel this exponent out, we're going to do the square root here. Remember to do the plus or minus sign if you're the one doing the square root. So we have plus or minus the square root of x minus 2 over 2 is going to be equal to y minus 3. Then we'll add 3 to each side. I like to put the plus 3 over here on the left hand side. So we're going to have y is equal to 3 plus or minus the square root of x minus 2 all over 2, and that's all under the square root sign. Move that up for you guys a little bit. There you go. And instead of this y here, we're going to write this as the inverse of x. When we did this change right here, we're not solving for f of x anymore. This y is not f of x. That y is the inverse of f of x. So we've got 3 plus or minus the square root of x minus 2 all over 2. What we want to do now is we want to verify this. So what we'll do here is we'll do 2 of them. We'll do f of the inverse, and we'll try to use these different colors here for you again. And then we're going to do the inverse, oops, that should be a minus 1 up there, our little inverse symbol. And then we're going to compose that with the original function here. Alright, so let's see how this looks. Well, f of x is right here, and f of x is going to be 2 the x, which we need to replace with this thing, so we got to leave a little bit of room, minus 3 squared, and then plus 2. So this inverse of f of x is this business, and what we will do then is we'll take the x out of the original f of x and replace it with this guy. Okay. On the right hand side, we're going to write this one down, and we're going to have to leave a space here for the x. We're going to take that and put in f of x. So let's try to write this down. We've got 3 plus or minus the square root, large space here, and then we'll write over 2. So this position, which is the x, is going to be this entire function right here. It's going to be 2x minus 3 squared plus 2. Alright, so now we've got our composition of functions, and you need to do each one of these. Let's get this all straightened out a little bit here. Okay, so we're going to work with these, and we're going to try to verify them as best as we can. So we're going to look inside here in these parentheses. I'm noticing that a positive 3 and a negative 3 is 0. So we've got the square root of x minus 2 over 2 all squared. The square and the square root will cancel. So we've got 2, and then I like to use parentheses here because we've got that entire quantity inside. Now this 2 and 2 will cancel. That's just 2 over 1, so the 2's are gone. Oops, I forgot to bring down the plus 2. Sorry. And then we've got x minus 2 now, plus 2. Negative 2 plus 2 is 0, so we just have x. That's good for us. That's the first part of the verification, and that tells us that we think now these are actual inverses. We need to get just x in the end. Let's see if that happens here. Inside this whole square root and in the numerator position, I'm seeing that 2 minus 2 is 0. And now we've got 2 times x minus 3 squared all over 2. The 2's will cancel. So now we've got x minus 3 squared. Now the square root and the square cancel. So we've got just x minus 3 here. We actually don't need the parentheses at this step. We don't have anything to multiply. So we've got 3 and negative 3, and we're just left with x. So what ends up happening when we compose each one of these functions together, these inverses and the function and the inverse together, this one's actually not a function, then what we'll get is we'll get x, and that's what we're looking for. To do the domain and range, what we can do is you can either graph this thing or you can reason through it a little bit, but let's go ahead and let's graph it and see what's going on. So we've got 3 plus square root, and I need to use parentheses again here. That's x minus 2. Oops, it should be minus 2. We'll divide by 2, and then we'll do the negative part here. So that's going to be another parenthesis, x minus 2, and then divided by 2. And we should be good. So let's hit zoom 6 and see what this thing looks like. There it is right there. So we need to figure out which point is right there. So I'm going to zoom in a little bit, see if we can get a better beat on it, and look at the equation and see if we can make sense of it. Oops, this is a little bit, here you go. A little bit out of the viewing window there. And it looks like that point has an x value of 2 and maybe a y value of 3. And that would make sense. It looks like we have here a shift right 2 and up 3. Okay. So what we can do to state the domain and range here, so we'll do that up in the upper right hand side. A lot of work for this one. So the domain is going to be all x values from 2 all the way to infinity. And you could also do this using your knowledge of square roots, and you have to set everything under the square root greater than or equal to 0. So if you remember that from a past learning target, you can actually take x minus 2 over 2, set it greater than or equal to 0, and solve there. And you're going to find that you get 2 is greater than or equal, x is greater than or equal to 2. So you can look at it a couple different ways. The range is just going to be negative infinity to infinity. This graph is just a parabola turned on its side. And each end will, you can see here in the graph, each end will continue on to infinity and then also down to negative infinity.